Welcome once again to Tech Garage. This is a very short video on this circuit that you see before you, which is a very simple circuit I bought. It is actually called the MC12. It's a pulse width modulator circuit with a simple 555 timer and a LM311 voltage comparator to create a variable duty cycle, variable frequency source to drive the coil. Now this will replace the amplifier and the signal generator source. I've adjusted the output of the 555 so that I have the same frequency as I had from the amplifier, which in my case is 7800 Hertz, and we do seem to get about the same results from this little circuit than we did the amplifier. However, in order for me to be using this circuit, I've discovered I have to use a load resistor across its output in parallel with driving the coil, or the circuit won't oscillate. And it's probably because of the MOSFET transistor being used. I'm not sure exactly why. I'll have to do some more investigation on that. But basically, it seems to work with a pretty significant load resistor across it. Now I'll pan up and show you this oscilloscope output that is actually right across it right now. There's no load on this circuit at the moment. So if we scan up here and look at the oscilloscope, we see we have, I think it's about 125 volts. Actually, it's more than that. Let's see. On the 50 volt per division scales, we got 1, 2, 3, 4, about 4 divisions. So that's about 200 volts without a load at all. Now, I say a load, I mean the load on the coil, because the load on the MC12 driving circuit is indeed present. It's right now 50 ohms. And there's a lot of power. It's a 10 watt resistor and it's getting quite warm. So we're dissipating quite a bit of power in that resistor, not in the coil itself. As I said, the coil is not loaded. There's no load on the coil. And if we was to take that load resistor off, I think we would get quite a bit more voltage if we could get the circuit to oscillate, but it's not doing that at this point. So I'll find out what the deal is with that driver. I've got several of the MOSFETs I could use. But I'm also going to try, with this apparatus, I'm going to try and drive the electrolyzer once again and play around with removing the load resistor and the electrolyzer as alternative loads, and maybe I can get somewhere with that. But we're just progressing here, trying to make some observations and trying to figure out a way that we can eliminate that amplifier as a driving circuit, as well as ultimately to be able to split the water into HHO gas from this process. So that may take some time, but we're slowly working at it. So I'm going to pan down to the apparatus here and show you the electrolyzer in a little bit of detail, which I didn't do before. I didn't remove it from the glass on the previous video, and I think I can give you a little better shot of what it looks like. What I'm going to actually do, instead of zooming down here to this, because there's really not much to see down there, is take the electrolyzer apart and show you if you can see it very well. This is the glass jar. It's just a simple pint-sized mason jar, and this is the actual electrolyzer design. It is nothing more than a quad. Basically a couple of pieces of plexiglass stuck together, and then I wrapped stainless steel wire around it. It's probably, my guess is slightly less than a 1/16 of an inch diameter wire. Haven't mic'd it, so I don't really know what its diameter is, but I wound two wires around there to act as plates. The one would be the positive, the other one would be the negative or whatever of the source. And maybe we can split some water with this. I pretty much replicated the same concept, the same design as those quart-sized water for gas electrolyzers, which I don't think are very efficient, don't do a very good job at all. Probably won't run a car for sure. But hopefully with some frequency applied and with this coil resonance, we might be able to get that to happen like Stan Meyer did. Whether that's possible or not with this apparatus, I don't know, but it was a test, and we can always construct something of more refinement if necessary. So that's what we're going to be using, and I'm going to only fill the reservoir with about a quarter to half full of water, just to reduce the amount of load, I guess. Just a guess. But that's where we'll start from today. Now, before I put the water in the electrolyzer and do all that, I wanted to check and see whether I could measure the difference in voltage, of the output voltage, with what was the condition I was looking for again? I don't think it was a difference in the load. It might have been. I was writing an email to a friend of mine, and I was discussing this issue of the duty cycle, which I can vary the duty cycle of the MC12 output, and that will act as a throttle control if we ever need such a thing. Any kind of duty cycle arrangement on your pulse width modulation will help to control how much energy is going into the coil, and therefore we should be able to use that as an electrolyzer gate, if you will, to control how much gas is generated if we need that. So again, right now we have the MC12. I'll go ahead and show you what we've got that driving, what we're driving with that. I don't have a cameraman, so I have to do this all myself. So, and I'm not the best at operating this thing, this camera here, but let me zoom back out and down. And let's see, there. It's not much to see, but there's the circuit right there. A MOSFET's on the heat sink. Again, it's not a very complicated circuit. It basically allows us to have a variable frequency and a variable duty cycle of that frequency on its output. And there's the 50 ohm 10 watt resistor that it's acting as a load on the output of that MC12 device. So again, I'm not sure why it doesn't drive the coil directly without that load, and I've tried 300 ohms and I've tried 1 kilo ohm, and the lower the resistance, at least to 50 ohms, seems to give a better result. So that's at any rate what we're looking at here. And there's the electrolyzer back in the glass jar. And so I'm going to pause this and resume when I have the water filled and the electrolyzer connected. So that's it for the time being.